One of the major unanswered questions in wildfire behavior is how long a fuel bed will burn. Related to this is how much heat is released as the fuel is consumed. How long and how intense a fire burns is critical to understanding how it spreads and the effects on the vegetation. Because real fuel beds are incredibly complex and uncontrollable from a scientific point of view, we study the burning behavior of these artificial fuel beds called wood cribs. Cribs allow us to precisely control the properties like the fuel element thickness, the spacing between the fuel elements, how densely packed the fuels are, and the overall dimensions. Each crib is carefully hand-built so that many different designs can be tested and they are repeatable from one test to the next. We study how the structure of the fuel bed interacts with variables like wind, moisture content, whether it is elevated above the ground or directly on the surface, and whether the fuel bed burns as an isolated clump or as part of a line fire. We light these fuel beds by dunking them in nearly pure isopropyl alcohol. When ignited, that alcohol burns off quickly but gives the sticks enough heat to ignite. While it burns, we measure the fuel consumption rate by measuring the change in weight using some load cells underneath. One unexplained phenomenon that we are looking at with these experiments is why big fires seem to burn differently than small fires. When fire starts consuming the large logs and the thick duff on the forest floor, our concept that fire spreads a line of fire starts to fall apart. When these long burning fuels are involved, the fire really burns as more of an area fire. As that area gets bigger and bigger, the plume above the fire gets wider and wider, which means that fresh air doesn't get pulled in as effectively. This has two consequences. The plume starts getting really tall, as we've often seen on big blow-up fires, and the air replacing all that smoke must come from somewhere, so it induces a strong wind down on the ground. We've never really understood how and if that changes the burning behavior. We are mimicking this large, tall plume in our laboratory studies by using a physical chimney to block the flow of air into the plume above the fire. As you can see, there can be dramatic change in the burning behavior of the fuels underneath, increasing the burn rate by up to 200%. As you can imagine, these cribs are very idealized, and our next steps are to apply what we learn here to real fuel beds and situations.